Okay, we are going to look at physical and chemical properties of group 15 elements. Under physical properties, we have what we call atomic and ionic radii. We have ionization enthalpies. And we have what we call electronegativity. We have metallic character. We have melting and boiling point, catenation, entropy, oxidation state. Yes. Then we need to start with atomic and ionic radii. Atomic and ionic radii increases down the group due to increase the number of shells in the outermost, due to the increase of the number of shells. When we come to ionization enthalpies, the first ionization enthalpy of group 15 elements are higher than the corresponding members of group 14. On going down the group, the ionization enthalpy decreases. The larger ionization enthalpy is due to the greater nuclei of charge, smaller size, and the stable configuration of the atoms of group 15 elements. So, the reason why the decrease in ionization enthalpy as we move down the group is due to the increase in atomic size. So, the ionization enthalpy, it increases down the group. It starts from nitrogen and ends with what we call bismuth. Due to the reason why the ionization enthalpy increases is due to the larger atomic size, increase in atomic size, and the screening effect which overweight the effect of increased nuclear charge, and what we call screened effect of the nuclear charges. Let us come to the electronegativity. Electronegativity, it decreases down the group due to the increased size of the atoms and the shielding effect of inner electron shells on down the group. When we come to the metallic character, remember nitrogen, it is non-metal. Nitrogen is non-metal. So when we look at the metallic character, the elements of group 15 are less metallic. However, on going down the group, the metallic character increases from nitrogen to bismuth. For example, nitrogen and phosphorus are non-metallic. Yes, bismuth is a metal. In group 15, the only metal that is there is bismuth. And the remaining two metals, it is what we call metalloids. Metalloids, when we talk about metalloids, these are elements that shows the character of what we call metals and non-metals. At the same time, we can call them same metals, since they show the character of metallic, at the same time the character of non-metallic. Catenation. For example, in the catenation, this is the ability of elements to show the bonds, to bond with metal, to bond with another metal. For example, like nitrogen. Nitrogen, it has three triple bonds. It is bonded with triple bonds. These bonds they are the ones that we call catenations. Entropy, this is the ability of metals to exist in two different forms, to exist in more than one different forms. For example, phosphorus exists as white. We have white phosphorus, we have black phosphorus, and red phosphorus. Arsenic exists as a yellow or gray. Antimony exists as yellow or silver gray entropic forms. So when we talk about entropy, it is the ability of metals to exist in more than one form. Oxidation state, when you look at the outermost shells, for example, let us look at nitrogen. Nitrogen, it has the electron configuration of nitrogen is 2 to 5. When you look at the outermost, this one, it needs 3 electrons to gain stability, or it can lose these 5 electrons. When it loses 5 electrons, it can become positive 5. When it gains electrons, becomes negative 3. oxidation state of these elements. This continues down the group. Now I'm going to invite my colleague to take us through what we call chemical properties.
So in chemical properties of group 15 elements, we have the reaction with oxygen. And when group 15 elements react with oxygen, they form two products. One is a trioxide and the other is a pentaoxide, where a trioxide, the general formula is represented by E2O3, where E represents the group 15 element. And an example is given of nitrogen reacting with oxygen to form nitrogen trioxide. Also, nitrogen does react with oxygen to give the other type of oxide, which is nitrogen pentaoxide. The other reaction is the reaction with halogens. And there are also two products formed here. We have a trihalide and a pentahalide. And this is the trend down the group. This is the trend to all the group 15 elements. So an example is given of nitrogen reacting with chlorine, a halogen, to give nitrogen chloride. Okay, so the third reaction is the reaction with metals. And group 15 elements react with metals to form binary compounds where they express or they show their positive 3 oxidation states. That's why in this example where nitrogen reacts with magnesium, we have magnesium nitrogen. I hope you can see that. It's Mg3 and N2. Yeah, Mg3 and N2. Arsenic also reacts with metals to form arsenides. And antimony reacts with metals to form antimonides, as the examples show. The last reaction that you're going to deal with under chemical properties is the reaction with hydrogen. And here they form this type. They form a general formula of EH3, where E represents the group 15 as we discussed above. So an example is given of nitrogen reacting with hydrogen to form ammonia. And arsenic reacting with hydrogen to form arsenide. It's arsenide. The other elements, for example, phosphorus forms phosphonine, and yeah, that's it for chemical properties of group 15 elements. Thank you.